So I found another mistake in the manual's video called Review of New Ferrocell Display Misconceptions, and I just thought I would make a quick video about it while it was on my mind and clear this up. So here's what he has to say.
Here in one of the action labs, the famous YouTube channel Action Lab, we made experiments with do-it-yourself ferrocells, with rough ferrocells, very thick glasses and large and square. And also he used, of course, he used LED strip as lighting, but because the surface area here is very big of the cell, and it's far away, it's quite, the light is very well diffused. So we can see here exactly what theory predicts. We will see here, we have here the classical field of the magnet, and here we see the projection. It's exactly what we expect. Here is the ferrocell. Okay, here we put the magnet above the ferrocell, doesn't matter if it's above, if below. So we here now, in this particular here magnetic field imprint, the observer, imagine you are here inside this cage and you look up and you see the lines from inside, from within the cage to the upper side. So you see here this line exactly as theory predicts.
So basically what he is saying is that these lines, okay, these curved lines correspond to these lines, which curve around and go through the magnet, and this is the magnetic flux lines. So he is saying that these are exactly magnetic flux lines. So what I'm going to do here is I created another one and turned it upside down so I could move this around. And so just to show you better that he is saying that the lines coming out of here correspond to the lines coming out of here. And I don't think I misheard him. I'm pretty sure that's what he said. Okay, so here's the problem. Okay, so this, in this diagram here, this is the North Pole, or say this is the North Pole. Let's say the red is the North Pole and the green is the South Pole. But I happen to know, so I actually have exactly the same magnet. It's a 2-inch by 2-inch by 1-inch neodymium magnet, and I happen to know that this is the block wall. This is what people call the dielectric inertial plane, and this is the North Pole, and on the other side is the South Pole, or this is the South Pole and the other side is the North Pole. Regardless, the pole is this face of the magnet here, and the dielectric inertial plane is here. However, in his diagram here, right, the North Pole is up and the South Pole is down. Okay, what we actually have in this experiment is this. And so if what he's saying is true, these lines should be coming out the side here. They should be coming out the side here and not out the bottom here. And so this is a really important point. When you put the magnet, when you put a North Pole on top of the ferrocell, you get the, hypertrochoid pattern. And when you put the magnet so that the inertial plane is, so that the pole is left and right, then you get this kind of pattern. Okay, and I could see how someone could get easily confused when you look at it sort of on this angle. So when this experiment was done, the camera was at an angle. The camera wasn't straight up over top of the ferrocell. It was off to the side. And so when you're off to the side, as I said in a previous video, it's very important to know where the camera is, where your eye is, and where the magnet is relative to the ferrocell. Okay, so here I took a picture in a similar orientation, and you can see these lines, and I could see how someone could get confused into thinking that these lines are these lines, but I know, because I just did this experiment 2 minutes ago, I know that this is the block wall, dielectric inertial plane, whatever you want to call it, and this is the North Pole, and this is the South Pole. And you can also actually see the pole kind of sticking out here, which you would never see. You would never see that in when you're looking at just the North Pole. So when the magnet, so I know the North Pole was up in this one. When the magnet with the North Pole up, you get this pattern, and when, let's say, the North Pole is here and the South Pole is here, then you get this pattern. And when you look at it from the side, you can actually see the pole actually here. I'm going to put these two together. So in Action Lab's experiment, you can see the pole kind of peeking out here, and in my experiment, you can see the pole peeking out here. And I know for a fact that the dielectric inertial plane is here, and I know for a fact, because I just did this experiment a couple of minutes ago, that the dielectric inertial plane is here. And so it is impossible. It's impossible for what Emmanuel said. It's impossible for that to be true, because the magnet is actually facing like this in the ferrocell. It's actually sitting like that in the ferrocell, and so the lines would be going in a different direction. And so this is a little problematic in terms of what he's saying in this video. Is a little misconceived. I think it's a little misleading to say this without actually doing the experiment himself. I'm not really sure why Emmanuel doesn't just do these experiments himself and you know, and come to the realization that this is an incorrect statement that he made here. Okay, this is definitely not, these lines cannot be magnetic flux lines. They just can't. It doesn't work out geometrically. This is a huge problem, and if this is the basis of his thesis, and so I also happen to know that Emmanuel is working on his PhD, and this is what he's feeding into his PhD. And so I don't know if I've mentioned this before, but part of my job in the work that I do in medical physics, in the medical imaging work that I do, is I help young people get their PhDs. And so when I see, I know it sounds like maybe I'm picking on Emmanuel right now, but I'm not. I'm actually really trying to help him. When my students, the students that I work with, when they make a mistake, it's my job to steer them right. Okay, it's my job to set the record straight. And so, ironically, at the beginning of this video, Emmanuel claimed that he was going to set me straight, and so that's a little bit of motivation for me to try and set him straight. But this is definitely not true, what he's saying here. These lines cannot be these lines whatsoever, and I think maybe he should be rethinking his thesis before it's too late. So, yeah, I'm going to leave it at that, and probably go Betty bye. Good night.